Alright, in this part of the review we're going to cover starting with section problem number 9, which is evaluating functions. So we're going to take these two problems and evaluate 2, negative x, and 2x in each function. So in this one, when we put in 2, we would evaluate to 3 times 2 and 2 squared minus 1. So we get 6 on the top, and 2 squared is 4, 4 minus 1 on the bottom, which is 6 over 3, which is 2. So that would be part A on number 3. Part B on number 3, we'd put in f of negative 2. That means we plug in negative 2 into this function. So it's 3 times negative 2, and then negative 2 squared minus 1. The difference here is the top is going to be negative 6. The bottom stays the same because when we square negative 2, we get 4 still. So we're going to have negative 6 over 3, which is negative 2. So f of negative 2 is negative 2, and f of 2 is 2 for A and part B. Part C, all it asks you to do is plug in a negative x instead of a positive x. So that means you're going to have 3 times negative x over negative x squared minus 1. Now we're going to simplify that as much as we can. We can't really do anything on the top except put the negative sign up there. The bottom, when we square a negative x, we're still going to get a positive x squared. So our answer is negative 3x over x squared minus 1. And in part F here, we want to find out the value of f of 2x. So we're going to put 2x in there. So 3 times 2x instead of 3 times x over 2x squared minus 1. So we're going to get 6x on the top when you go 3 times 2x. 2x times 2x is going to be 4x squared. It's because you got 2 times 2 and x times x. So this is our solution. 6x over 4x squared. We can't divide. That's as simplified as we get for f of 2x. Now let's do the same evaluations on problem number 4 here. So problem 4, we'll put over here f of 2 is going to be the square root of 2 squared minus 4. 2 squared is 4, so it's 4 minus 4, which is the square root of 0, which is 0. So f of 2 is 0. Now f of negative 2 is going to be negative 2 squared minus 4, which is still 4 minus 4, because negative 2 squared is positive 4, so we're still going to get 0 out of this one too. So f of negative 2 is 0 as well. F of negative x, we're just going to put the negative x in there. Instead of a positive x, we're going to square it and subtract 4. We actually end up with exactly the same formula. Later on, we're going to call that even because it didn't change the formula. And then the last one, we're going to put in f of 2x. So we're going to get 2x squared minus 4. Because anywhere there's an x in the formula, there's only one here, this x becomes whatever value is in the parentheses, in this case 2x. So when we square that, we're going to get 4x squared minus 4. Now we can factor out a 4 on this one and simplify it because the square root of 4 is possible. So if we factor out a 4 and factor it out, 4 times x squared minus 1 is 4x squared minus 4, and this 4 is 2 when we take the square root, so it's 2 square root of x squared minus 1 is simplified for that problem. Alright, so that's evaluating functions by plugging in values in function notation. Now, step 10 on the review asks you to find the domain of the function. Well, the domain is restricted when we have two possibilities, a denominator and a square root. So in this case, those that have denominators are going to be restricted because they can't divide by 0. So denominators cannot equal 0. And square roots of values have to be positive, have to be greater than or equal to 0. They have to be positive values. So those are the two things that I'm going to be looking for. It cannot equal 0 or greater than or equal to 0. So on number 6 here we have a denominator. So what I would say is the denominator cannot equal 0. That's our domain. So in this case this factors, or we can think of it as solving. You can solve it as well. Take the minus 9 and move it over, and you would get positive 9, and we take the square root of both sides. So we would get plus or minus the square root of 9, which is plus or minus 3. So in the domain of this would be all real numbers, except the values 3 and negative 3. Oops, this looks like a bracket too. So 3 and negative 3. Now you can use symbolisms here and say capital R for all real numbers minus, which would be except, and then the parentheses would be listing your exceptions. So this would be another way to say it instead of writing all real numbers, or you can say you can use set notation also here and write it as the set of all x's such that x does not equal 3 or x does not equal negative 3. So that would be a set notation for that. Now in number 7 we would then set the 2 minus x has to be greater than or equal to 0. So if we're solving that, we subtract the 2. We get minus 2 over here. We'd have to divide by negative 1, but in dividing by negative 1 we have to change this symbol. So that symbol has to change to less than or equal to. So x is less than or equal to 2. So your domain there would be negative infinity to positive 2. Or you could write it in set notation as a set of all x's such that x is less than or equal to 2 for that notation. So either one of those is how you can write that for 7. And then there's several ways to write number 6. Okay. All right, number 9 is similar in that we would look at the denominator, and it's similar to 6 in that way. So if we were doing number 9 similarly to 6, we would take the square root and or we'd factor it, I mean. Let me find some more room for this. More room. So let's take a look at the denominator here. The denominator is x squared plus 2x minus 3. So we'd say on number 9, we'd say x squared minus 2x plus 3 cannot equal 0. So plus 2x minus 3. Oh, I have the signs backwards. So that means that what we would do here, I would factor, because there's only one way to factor this with 1 and 3 to get the value of 2, and it would be positive here, Positive 3 minus 1 would give you a 2. So then you would say x minus 1 cannot equal 0, or x plus 3 cannot equal 0. So x cannot equal 1, or x cannot equal negative 3. And those would be your exceptions. So you'd say all real numbers except for those two things. All reals numbers except 1 and negative 3. Now on the last problem here, which was number 11, we have a denominator and a square root. So that means on a regular one it would be greater than or equal to 0, but we can't have it equal to 0 because it's in the denominator. We can't divide by 0, so we're going to say just greater than. We're going to take the denominator, x plus 8, so on 11, x plus 8, what's under the square root has to be greater than 0, because if it's not, you can't take the square root and you can't divide by 0. We wouldn't be equal to, we couldn't equal 0. Even though the square root can happen there, we can't divide by 0. So in this case we'd say x is greater than negative 8 is our domain in solving it. X is greater than negative 8. Or you can also say negative 8 to infinity for your domain. All right, so that's problem number 10 on your review. Problem 11 starts out this way. It asks you to give the combination of functions and asks you to state the domain. Now we only asked you to do number 12 here on the review. So the first combination function is f plus g. All you're really doing is adding these two things together. So you're just taking 2 minus x plus 3x plus 1. So that's a new function. You can combine like terms and get 2x, and you combine like terms here and plus 3. So that's the new function for f plus g of x. So if you wanted to write f plus g of x, you would say that that's the same as 2x plus 3, and that would be the answer. The domain on this one's all real numbers because it's just a regular function. It doesn't have a denominator or a square root. Now f minus g is just the same thing. You're going to take your 2 minus x, which is the f function, and you're going to subtract the g function. Instead of adding it, you're going to subtract it. So you put a minus, you subtract the whole g function there. So when you do this, you change the signs on the second part. So you have a minus 3x minus 1. You combine those together, like terms, you're going to get negative 4x plus 1, and that's going to be your f minus g function of x is negative 4x plus 1. Its domain is all real numbers as well. Now f times g of x is where we multiply them together. Now we'd want to do that by using either a FOIL method or by making sure you do repeated distribution. We got to multiply everything in the front parentheses by everything in the back parentheses. So you could do that by doing distributive twice or 4 times, or just doing FOIL, which is the same thing. So we're looking at that, we're going to multiply this times this. That's going to give us 6x. We're going to multiply this times this. That's going to give us 2. We're going to take our second term here, which is negative x, and multiply, which is negative 3x squared. And then we're going to take our x and multiply negative x times 1 and write minus x. Then we combine like terms, which are these two. Write it in order. So we start with negative 3x squared. We combine these two together, we get 5x, and end with 2. So that's our function for f times g, and it doesn't have its domain is all real numbers. Now the last one here is f divided by g, and I think I'm going to have to run into the next one because I'm running out of time. So we'll start there on the next one.